Earth Surface Review, Gorakhpur. He was the secretary of Institute of Indian Geographer and the founder secretary of Association of Bengal's Geographer. He is the editor of newly launched journal Contemporary Geographer. He has successfully guided 11 MPhil and 11 doctoral dissertations. He has also completed one major research project entitled Tribal Livelihood and Sustainable Development in Mayurbhanj, Orissa, sponsored by ICSSR, and one small research project and Wasteland, sponsored by NRDMS of DST. Dr. Janasa has been nominated as a steering committee member in IGU Commission on Research Development in Geography. Currently, Dr. Janasa is professor, a former head in the Department of Geography, University of Burdwan, West Bengal, India. Sir, we are very delighted to have you here and welcome you to start with your session. Sir, please.
Thank you, Upasana, for your nice introduction. Actually, the topic which I am going to deliberate is the culmination point of all the technology which we have adopted from time to time in the digital world. So, just I am trying to give you a comprehensive overview of the digital cartography, because you know the subtopics covered in this deliberation, one can deliver 2-3 hours lecture on each of these subtopics. So I am just sharing the okay. No, it is not coming. Okay. Digital cartography. Yeah. Just a minute. No. Is it coming?
Yes, sir.
Okay. So what I have pointed out, that I would like to give you a comprehensive overview, that I have already pointed out that you can deliver lecture. I mean, a resource person can deliver lecture in one of the subtopics because it is so vast. I am just trying to give you an overview of all the subtopics which I have covered in the deliberation of my lecture. So we have already entered into the digital world. I mean, particularly in the first quarter of the 21st century, we are very much in the forefront of digital world. Particularly, India is going through the digital world, and the government of India is now giving emphasis on the digital deliberation of in all the sectors of the society. So these are the outline of my lecture, Cartographic Evolution. That means I will give you an overview of the history of cartography, how map has evolved to the most traditional one to the most modern digital one. And I will be highlighting the practical applications of modern cartography. Then I will be switching over to map classification. Then I will be going through little bit on map elements, and the last but not the least, the principles of map design. So cartographic evolution. So as the participants belong to different disciplines, I am going through the most elementary definition of cartography. I mean, it is a method where maps are studied, created, and designed. It is nothing but a confluence between practice, science, and art. Actually, cartography guides us the principles and practical standards behind maps and map making. So, maps are important, and very much important are map making. So, when it is overlapped between geography, earth science, topology, and even politics, cartography is a highly intersectional discipline. Cartography helps.
सर सॉरी टू इंटरप्ट यू, आपकी स्लाइड मूव नहीं कर रही हैं.
Hello.
स्लाइड्स. हेलो सर, स्लाइड मूव नहीं कर रहा है.
स्लाइड मूव नहीं कर रहा है.
नहीं. अब आ गया.
अब आ रहा है ना. एक्चुअली जब मैं वो प्रेजेंटेशन व्यू पे दे रहा हूँ ना, थोड़ा शायद प्रॉब्लम हो रहा है. तो ये विजिबल है ना.
सर स्लाइड शो मोड कर दीजिए इसको.
स्लाइड शो मोड कर दीजिए. यस सर.
विजिबल.
स्लाइड शो मोड कर दीजिए सर उसको, वही से सर जहां से आप कर रहे थे अभी.
नाउ इट इज विजिबल.
यस सर, इट्स विजिबल.
नहीं, आई थिंक स्लाइड शो मोड पे है, लेकिन वो पूरा स्क्रीन शेयर करना पड़ेगा एक बार.
ठीक है चलो. ठीक है सर, दिखाई दे रहा है.
ठीक है सर.
जस्ट अ मिनट. एक्चुअली स्लाइड शॉटर व्यू पे वो विजिबल है, लेकिन जब मैं दे रहा हूँ प्रेजेंटेशन व्यू पे स्लाइड शो.
Sir, this is Dr. Suraj this side. Good morning. We'll help you out. What you do is deselect, stop sharing it, and when you will select the option share the entire screen instead of sharing window.
Okay.
Now this time when you will share the entire screen of yours, and then you share this PPT. So all this problem will be resolved.
Your entire screen.
Yeah.
But the presentation is not coming actually.
Sir, now open up.
Presentation is open, you know.
Now you share the entire screen. Yeah, now open up, sir, your PPT. Sir, now open up your PPT. We can see. Yeah, sir.
How is it coming?
Yeah. Sir, slideshow mode. Can you select the slideshow mode option? Slideshow mode option.
It is coming?
Perfect, sir.
Yes, sir.
Perfect.
Yes, sir. Yes, sir.
Okay. So, cartography actually helps us understand our place in the world, analyze positional relationships, and reflect on geography's effect on our daily lives. It is important to note that cartography deals in representations of the world, representation shaped by the purpose of the map and the intentions of the map maker. Throughout history, I am just touching upon the main points because I have already pointed out that 87 slides are there. I'd like to share all the slides so that I will be able to give you a comprehensive view of the entire theme. Throughout history, maps have been used to reflect current events, manipulate politics and trade, and even illustrate religious beliefs. For centuries, cartography has helped map our changing world because we are now very much familiar with the change detection in the arena of remote sensing and GIS. But that change detection in the conventional method, it was very difficult to show the changing panorama of a particular place. It is now very easy to give a change detection view in the arena of remote sensing and GIS. As technology evolves, because with the evolution of technology, we can map our city, country, planet, and to an extent even our universe also. Now, the last one, geographic information system, it is the ultimate culmination of cartography and modern technology. So, hence, the importance of digital cartography, which allows us to map our world like never before, from rendering 3D oceanic base maps to finding the nearest dry cleaner. The technology itself is undeniably impressive, and cartography is its foundation. So you cannot deny the traditional cartography, because traditional cartography is the foundation and which have been modified and sophisticated with the advent of the modern technology. So, history of cartography. It traces the development of cartography because, it is the most important human interventions for millennia and allowing humans to explain and navigate their way throughout the world. So we can map the world, we can navigate our paths to visit different places of the world. The earliest surviving maps include cave paintings and etching. I mean, cartography initially evolved through cave paintings and etchings on tusk and stone. The map I will show, there are certain glaring examples of these cave paintings and etchings where the geographers and surveyors, they have tried their level best to map of a particular place, although these were very unscientific and did not maintain many things. But still, they have initiated the mapping of a particular place on paintings and etchings. Followed by extensive maps produced by ancient Babylon, Greece, Rome, China, and India. Particularly Babylon, Greece, Rome, and China, where the Babylon and Greece, they are considered to be the pathfinders in the evolution of map making and the traditional cartography. In the most simplest form of maps, maps are two-dimensional. Since the age of classical Greece maps have also been projected into a three-dimensional sphere known as globe. But this cartography has been evolved in India much later. But Babylon, Greece, followed by Rome and China, they were the pathfinders, as I have already pointed out. The Mercator projection, developed by Flemish geographer Gujrat Mercator, which was widely used as the standard two-dimensional projection of the Earth for world maps until the 20th century, when more accurate projections were formulated. So you just imagine that the Mercator projection, which was developed by the Flemish geographer, is considered to be the ideal one until the late 20th century. And there are widespread use of the cartography and very specifically the maps. Modern methods of transport, the use of surveillance aircraft, and more recently the availability of satellite imagery have made documentation of many areas possible and were previously inaccessible. So lots of things are possible through the modern technology, which was nothing but the switching over from the traditional cartography to the recent one, the satellite imagery. Even now, the free online services. Hello?
Yes, sir, you are audible.
Yeah. Free online services. Now, during the COVID-19 pandemic, for the almost last 2 years, the pandemic started. India went for lockdown during the last week of March. So we are yet to complete 2 years of COVID-19 pandemic. We are suffering a lot. So that time the free online services by Zomato and Amazon, which have been possible, and Google Earth Play have made accurate maps of the world. I mean, GPS uh, application of GPS now playing a vital role in delivering the goods and commodities to the stakeholders. Now, so far as the history of cartography or the evolution of cartography is concerned, the journey begins. How? I mean, the mapping can be traced to more than 5,000 years ago, and which are uh, essential tools for the map maker, record the location of places of interest, or others are a source of learning about the geography of the mapped area. So, maps and mapping are the vital part not merely for the geographers, but for the decision makers and planners, whatever may be their disciplines. I mean, where they are engaged, whatever may be their sectors, but maps and mappings are very important to all the people of all the sectors in the society. Mapmaking date back centuries, even millennia. The oldest maps are cave wall paintings and stone tablets. So, firstly, maps were observed in cave wall paintings and stone tablets, and it took hundreds of years to produce a navigable projection in the world. So, first map were found in the cave wall and stone tablets, and followed by the navigation. Ancient maps. The oldest known map in the world is dated back to 7th millennium BC. It was found in the Anatolian city in modern Turkey. This ancient map was found painted on a cave wall, not on a paper, not on a cloth. It showed a volcano and 80 buildings. It's 9 feet wide and believed by some to be a town plan. So all those maps were the initiatives at the ancient times, but these were not scientifically correct, but definitely these maps were the pathfinders in the history of cartography. So see, the cave drawings believed to be ancient map of Anatolian city in Turkey. I mean, I have put a note here that it should be noted that there are different interpretations of this drawing, as is not clear, and there is no clear-cut evidence. You know, you will find many more cave paintings, but which is not clear at all. But still, we appreciate those cave paintings because it was the earliest initiatives by the cartographers. This is nothing but a tablet in 600 BC, which is in the collection of British Museum, is an excellent example of Babylonian clay tablet maps. I mean, it is a tablet map built on a clay. It shows Babylon in the center with the Euphrates River, mountains, and the surrounding ocean. But you can imagine, I mean, how much they took initiative in the ancient period to produce a map and mapping of a particular region, although these are not very clear. Ancient Greece. Ancient Greece is considered to be the pathfinder in cartography, maps, and map making. So we can mention with appreciation the names of Anaximander, Ptolemy. Anaximander was the first ancient Greek to draw a map of the known world. And Greek philosopher Anaximander is believed to have created the first published world map. So he is considered to be the pioneer in this regard, that he has first published world map. Ptolemy was a geographer mathematician and astronomer who lived in Roman Egypt. Although he was a Greek, but he lived in Roman Egypt. In about 150 AD, he famously published a scientific treatise titled Geographia. That means in English, he published a book on the basis of this book contained thousands of references and maps of various parts of the world with longitude and latitude lines. This system revolutionized European geographic thinking by imposing mathematical rules to the composition of map. That means Ptolemy's work, who wrote a book named Geographia, so which is considered to be the revolutionary work for European geographical thinking. And Ptolemy's work continued to be of great importance to European and Islamic scholars well into the Renaissance. So it was nothing. It has been considered as the Renaissance in the field of cartography. Ptolemy's work. So see the map, reproduction of Anaximander's world map, because Anaximander's world map lost. So it was a reproduction form of the world map. The earlier map made by Anaximander was lost. So this is Ptolemy's world map. See how it is highly artistic, you know. It is a version of the Ptolemy's world map produced in 1482 using the information content in the Geographia. So where he put the lines of latitude and longitude, and he presented this map in a very stylish form, and it was very much highly artistic, as is evident from the design of the map. Now, Hecataeus is one of the important Greek geographers who describes the Earth as a circular plate with an encircling ocean and Greece in the center of the world. This was very popular contemporary Greek worldview. Another Greek geographer, Anaximenes of Miletus, who studied under Anaximander, who was a disciple of Anaximander, who rejected the views of his teacher regarding the shape of the earth, and instead he visualized the earth as a rectangular form supported by compressed air. I will show the map. Rectangular shape map of Anaximenes. Pythagoras of Samos speculated about the notion of a spherical earth with a central fire at its core. He divided the spherical earth into 5 zones, 1 hot, 2 temperate, and 2 cold, northern and southern. This idea known as the zonal theory of climate. Telex, who is basically a sailor, made a record of his Mediterranean voyage, and he has given the sailing instructions, which become the basis for many future map makers, especially in the medieval period. Herodotus, one of the most pioneering geographers, traveled very extensively, collecting information and documenting his findings in his book on Europe, Asia, and Libya. Actually, on the basis of his traveling all over the world, he wrote a book on Europe, Asia, and Libya. And his work, his book provides a detailed picture of the known world of the 5th century BC. So you can, the geography, the geographers, contemporary geographers of the Herodotus, they could use the details of the books for map making. See the world according to Hecataeus. He considered world as a circular form, and world according to Anaximenes, who considered it a rectangular form. And this is the the world according to Herodotus in 440 BC. Now coming to the Roman contribution, we can, the name of Pomponius Mela, Marinus of Tyre, which are worth mentioning. And Pomponius Mela is unique among the ancient geographers because after dividing the earth into 5 zones, of which 2 only were habitable, he divided the earth into 5 zones and 2 were habitable only. Marinus of Tyre, I am just touching upon, I am not going into detail because many more slides are left. And I have to cover all the sub-themes of digital cartography. Marinus of Tyre, who founded mathematical geography and provided the underpinnings of Ptolemy's influential geography. And he introduced the improvements to the construction of maps and developed a system of nautical charts. In 2007, Tabula Peutingeriana, a 12th century replica of 5th century road. I mean, this is nothing but a map. Tabula Peutingeriana was not a geographer. It is a place actually, a map. So, which provides a replica of 5th century. It was made in 12th century. 12th century replica of 5th century road. Was placed on the UNESCO memory of the World Register and displayed to the public for the first time. Although the scroll is well preserved and believed to be an accurate copy of an authentic original. So, reconstruction of Pomponius Mela's world map and the modern version of Roman Tabula Peutingeriana. So, China has made notable contribution in the field of cartography. You know, although information about China, to collect information about China's cartography is difficult till today. Even at the onset of the, now we are just crossing the first quarter of the 21st century, you cannot get each and every detailed information about China. Whatever, the oldest reference to a map of China comes from the 3rd century BC. So there were a number of dynasties who appointed cartographer or geographer to produce and to make maps. So 3 Han Dynasty maps found at Mawangdui. It is very, very difficult to pronounce and very difficult to understand also, because the analysis of the Chinese cartographer and their contribution is very difficult to comprehend. The Han maps are also more complex since they cover a much larger area, employ a larger number of well-designed map symbols, and include additional information on local military sites and the local population. Because China always gives much more emphasis on military, because now in contemporary time, what we are witnessing or what we are observing, that China has the aggressive attitude. They have the attitude of aggression. वो हिंदी में कहावत है ना, विस्तारवादी जो भावना है चाइनीज का, वो किसी भी कंट्री के लैंड एरिया को कैप्चर करने का कोशिश करता है, विस्तारवादी भावना. So they have the attitude and mindset of aggression. So always they gave much more emphasis on military sites, local population, and the information of the surrounding countries, so that they can capture their land area, which are being happened today only. Zhou, who is considered best known for his work in cartography, and who is considered the Ptolemy of China. He was the first to mention a plotted geometrical grid and graduated scale displayed on the surface of the maps to gain greater accuracy in the estimated distance between different locations. Now, Sui dynasty, uh, I mean, uh, Sui dynasty, the commercial commissioner Pei Jiu created a famous geometrically gridded map. Tang dynasty, the Tang dynasty also had its fair share of cartographers, including the works of Zhu Jingzong in 658, Wang Mingwang in 661, and Wang Zhongxi in 747. Song dynasty, Song, this is not Song, but Song. During the Song dynasty, the Emperor Saizu of Song ordered Liu Daishan in 971 to update and rewrite all the Tuzing in the world. You cannot get any information in English, you know. I visited Beijing in 2016 for attending International Geographical Congress. I mean, nobody understands English. You know, you go to shop, you go to any car driver, only they know China. Even they could not understand the Great Wall of China, you know. I mean, my colleague, he converted the Great Wall of China into Chinese language. Great Wall of China. So it is very difficult to get the detailed information, not merely in cartography or maps, any information, political map, political information, cultural information, their society, it is very difficult. Yuan dynasty, I mean Mongol Empire, because that time Mongol was with Mongolia, which is China. Even Korea, I mean the undivided Korea was with China. They have been liberated with the passage of time. I'm like India, undivided India. In the Mongol Empire, the Mongol scholars with the Persian and Chinese cartographers, all their foreign colleagues created maps, geographical compendium. So they have, you know, you just imagine their contribution. Geographical compendium they have created, as well as travel accounts. Mi dynasty, the Mi Hui to map dating from about and it is in multicolor. I am not going into detail. Qing dynasty from 16th to 17th century. Several examples survive of maps focused on cultural information. Modern PRC. So now switching over to the modern Public Republic of China. After the 1949 revolution, the Institute of Geography, under the aegis of the Chinese Academy of Sciences, became responsible for official cartography and emulated the Soviet model of geography throughout the 1950s. So they followed the Soviet model of geography. Now you can visit the Institute of Geography is there, Chinese Academy under the Chinese Academy of Science. You can visit there as a visiting fellow, which is very strong organization all over the world. Institute of Geography, Chinese Academy of Sciences, with its emphasis on fieldwork, sound knowledge of the physical environment, interrelation between physical and economic geography. The Russian influence counterbalanced the many pre-liberation Western trained Chinese geography specialists who were more interested in the historical and cultural aspects of cartography. So now the Institute of Geography under the aegis of Chinese Academy of Sciences, they made a significant contribution to the field of cartography. So see the maps. The upper one, an early Western Han dynasty. Silk map found in tomb 3 of Mawang Dui Han tomb site. So it is on the tomb, it is not a cloth or paper, whatever. And depicting the kingdom of Sangsa and kingdom of Nanui in southern China. So that time, monarchy dominated. The information about the monarchy or the king, whether it is northern China or southern China, it took a dominant place in the cartography, whether the map is cave paintings or in the tomb walls or whatever. The UG2 or map of the tracks of Yugong carved into stone in 1137, located in the still forest of Jia. So it is carved into a stone, and this in the geographical chapter, I mean, you see the coastline, the drainage pattern in this curved stone. It is very clear. So the me who U2 map dating from about 1390 is in multicolor. The horizontal scale is there and the vertical scale is this. So now we will be gradually witnessing the color map. Earlier it was the black and white and mainly found in the cave stones or in the tomb walls or whatever. India. So the contribution of Indian cartography, I mean contribution of geographers or the experts in the field of cartography, it came later. The Indian cartographic traditions covered the locations of the pole star and other constellations of the universe. These charts may have been in the use by the beginning of common era for purposes of navigation. The 18th century scholar Bhavabhuti conceived paintings which indicated geographical regions. Maps from the Aini Akbari, because Mughal period was there. So maps from the Aini Akbari, a Mughal document detailing India's history and tradition, contain references to locations indicated in earlier Indian cartographic texts. Sorry. So the man, the personality, the Pandit, cartographer, Nain Singh Rawat, I don't know from which state he belongs to, maybe from Rajasthan. Nain Singh Rawat received the Royal Geographical Society Gold Medal in 1876. So, Nain Singh, the name of Nain Singh is appreciable as he got the Royal Geographical Society Gold Medal. And the contribution of Arab and Persian geographers in the field of cartography. In the Middle Ages, Muslim scholars continued and advanced on the map-making traditions of earlier cultures. Most used Ptolemy's method. So initially, they used Ptolemy's method, but they also look advantage of what explorers and merchants learned in their travel across the Muslim world. So actually, what happened that time, there were certain explorers and travelers who widely visited or traveled all over the world, and they considered the knowledges and experiences of the explorers and merchants and put into while preparing the maps. In the Islamic world, the study of science and map making, geography did progress. I mean, there is a significant, there is a significant contribution of, I don't know how much Persian geographers have contributed, but there are significant contributions of Arabian geographers. And an excellent example of this work of Al-Idrisi. Al-Idrisi, you have gone through, I mean, geography people have gone through the significant contribution of Al-Idrisi, an Arab scholar, because Al-Idrisi, the Arabian geographical thought, those who belongs to the discipline of geography, they are quite familiar with Al-Idrisi's contribution. In the court of King Roger II of Sicily, in the period around 1154, he produced a number of outstanding world maps and geographic books. So Al-Idrisi wrote a number of books, and he also produced a number of world maps. Also in the 9th century, the Persian mathematician and geographer Hawas al-Hasi al-Marwazi, who employed spherical geometry, trigonometry, and map projection methods in order to convert polar coordinates to a different coordinate system. I mean, as he was a mathematician, come geographer, so he employed the spherical trigonometry in his, while preparing the maps or putting his mathematical knowledge in the preparation of maps. Ibn Battuta, you know, Ibn Battuta wrote Riala. Riala means travels. Based on 3 decades of journey covering more than 1,20,000 kilometers through northern Africa, southern Europe, and much of Asia. So he was basically, Ibn Battuta was a traveler, and he was a historian, you know, Ibn Battuta. So he traveled 1,20,000 kilometers. And he wrote a travelogue, Riala. Travelogue is also an information, how to move, where to move, from which side you can move. Al-Idrisi map of the world, produced in 1154. The original of this map no longer exists. This replica was produced in, I have already pointed out that it was lost, and the replica has been produced in 1456. The right side map is the Al-Masudi. You are quite familiar with the Al-Masudi's name, particularly the geography people. Al-Masudi's world map, 10th century. So, S.P. Scott, who made an appreciable comment on the work of Al-Idrisi. I am just reading out his comment. The compilation of Idrisi's marks an era in the history of science. Not only is its historical information most interesting and valuable, but its descriptions of many parts of the earth are still authoritative. For 3 centuries, geographers copied his maps without alteration. The relative position of the lakes which form the Nile as delineated in his work does not differ greatly from that established by Baker and Stanley more than 700 years afterwards, and their number is the same. The mechanical genius of the author was not inferior to his erudition. The celestial and terrestrial planisphere of silver, which he constructed for his royal patron, was nearly 6 feet in diameter and weighed 450 pounds. Upon the one side, the zodiac and the constellations, upon the other, divided for convenience into segments. The body divided for convenience into segments, the bodies of land and water with the respective situations of the various countries were engraved. Al-Idrisi's atlas, originally called the Nujat, Arabic language में इसको Nujat कहा जाता है, atlas, served as a major tool for Italian, Dutch, French map makers from 16th century to the 18th century. So now you just imagine Al-Idrisi's contribution, particularly the writing, his writings and his atlas, which was followed in Italian, Dutch, and French by French mapmakers. Medieval Europe, medieval maps of the Mappa Mundi. Mappa Mundi is nothing but the cloths or charts of the world. Mappa Mundi, a Babylonian world map known as Mappa Mundi. These maps were circular or symmetrical cosmological diagrams. So far as Italian cartography and the birth of ortolan charts are concerned, the Carta Pisana ortolan chart made at the end of 13th century is the oldest surviving nautical chart. I am just moving fast because so many slides are, just see the Gaup map, a road map of 14th century Britain. and the lower one, the map of the Holy Land, Pietro Vasconte, 1321, described by Adolf Erik Nordenskiold as the first non-Ptolemaic map of a definite country. So this is important from this viewpoint, from this context, that this map was the first non-Ptolemaic map, because all the geographers, they follow the Ptolemy's work, you know. I mean, keeping in view the Ptolemy's work, they modified a little bit with the passage of time. But this map was the first non-Ptolemaic map of a definite country. That's why it is very important in this context. The Fra Mauro map, a medieval European map, was made around 1450 by the Italian monk Fra Mauro. It is a circular world map drawn on parchment and set in wooden frame, about 2 meters in diameter. You know, that time it has been prepared in wooden block, and it was prepared by Italian monk Fra Mauro. These points are to be noted. These are very important because in Europe, the Renaissance period brought a number of significant changes which hugely affected mapping. Renaissance definitely have important impact on in the field of cartography. Not merely Renaissance brought significant changes in economy or society, it had significant impact on cartography also. What are those? The invention of printing press by Johannes Gutenberg in 1440 means that monastery no longer dominated map production. So sometimes monarchy, sometimes monasteries, they dominate the map making. The discovery of the Americas and expanded contact with the Orient resulted in greater interest in distant places and migration. So, I mean, Americas were discovered, and the Orient. Orient means the Oriental world, like the Asia, Oriental world. These are called Oriental world. The growth of major publishing houses which produced maps that were accessible to all. So now, map publishing were started due to Renaissance. The growth in the public learning brought a thirst for knowledge. This was added by the establishment of institutions such as French Academy of Science, which was established in 1666 to encourage scientific research. So academic institutions came into existence. Maps were produced, publishing maps were started. So many continents were explored and discovered. So these are the results of the Renaissance in Europe. All these led to a massive expansion in geographic knowledge and mapping. And earlier maps in this period tended to be simple black and white maps, which showed coastlines, country borders, mountains, rivers, place names. In many cases, these are then hand painted to add some color to the finished product. So gradually, in the traditional cartography also, the most coarse or rough one, now the map makers or the cartographers, they had given a finished touch to the map. In the late 70s, maps which showed the theme started to emerge. So administrative maps, maps dominated by monarchy, maps dominated by monasteries. Now theme has emerged, thematic map. Through the ages, maps have become more complex and more accurate. So it has gradually becoming complex and accurate, particularly as understanding of the art, mathematics and geography has expanded. So with the growing knowledge in mathematics and geography, maps have become complex and more accurate with the passage of time. Age of exploration. Age of exploration means it is nothing but the introduction of telescope, compass and the sextant. So Iberian cartography in the age of exploration. What is Iberian? Because during the 15th and 16th century, Iberian powers, Kingdom of Castile and Kingdom of Portugal. So this is Iberian powers. Spain, Portugal were magnets for the talent, science and technology from the Italian city-states. So Portugal and Spain, they are considered to be the magnets for the talent. I mean, hub of talent. This is considered to be the hub of talent. So I am not going into detail. I am switching over. First maps of the Americas in the medieval, in the age of exploration. So 1500, the Spanish cartographer and explorer Juan de la Cosa created the first known cartographic representation showing both the Americas as well as Africa and Eurasia. Eurasia means Europe and Asia. In 1502, unknown Portuguese cartographer made the Cantino Planisphere, the first nautical chart to implicitly represent latitudes. 1504, Portuguese cartographer Pedro Reniel made the oldest known nautical chart with a scale of latitude. Again, in 1519, the Portuguese cartographer Lopo Homem and Pedro Reniel and George Reniel made the group of maps known today as the Miller Atlas of Lopo Homem. In 1530, Alonso de Santa Cruz, Spanish cartographer, produced the first map of magnetic variations from the true north. So see the map, world map by Juan de la Cosa, the first map showing the Americas. He showed both the Americas, North and South America. Initially it was Americas, then it divided into North and South America. And the nautical chart produced by Pedro Reniel, one of the first based on astronomical observations and to depict a scale of latitudes. So from that point, or from that context, it is a revolutionary initiative by Pedro Reniel. Spanish Empire. Spanish House of Trade founded in 1504 in Seville had a large contingent of cartographers, among which Diogo Ribeiro is considered to be, his contribution considered to be most important because this Portuguese cartographer working for Spain, although he was a Portuguese, but he contributed for Spain, made what is considered the first scientific world map. Padrón Real, this scientific world map produced in 1527 was popularly known as Padrón Real. The layout of the map. So in Portuguese, map is known as Mapamundi, Mapa Mundi. Two prominent cosmographers as mapmakers were then known. तब mapmaker को cosmographer कहा जाता था. I mean, they were popularly known as cosmographers, but they are basically mapmakers. Of the House of Trade, there are Alonso de Santa Cruz and Juan Lopez de Velasco, who directed map mapping under Philip II. And their maps were based on information they received from returning navigators. They have also compiled the information they have gathered from the returning navigators. German cartography. 15th century, the German monk Nicholas Germanus wrote a pioneering Cosmographia. He added the first new maps to Ptolemy Geographica. In 1492, German merchant Martin Behem made the oldest surviving terrestrial globe, but it lacked the Americas. In 1507, German cartographer Martin Waldseemüller world map was the first to use term America for the Western continent. And in 1603, German Johann Bayer's Star Atlas was published in Augsburg in 1603. It was the first atlas to cover the entire celestial sphere. See the world map by Diogo Ribeiro, who made significant contribution to Spain, although he was a Portuguese. And Martin Beham's Eradefel is considered to be the oldest surviving terrestrial flow. Netherlands schools. Notable representatives of the Netherlands school of cartography and geography are Frankish Monarchs, Jemima Freisas, Jespard van and so on, among which Johan Bleu contribution is considered to be very important. And the golden age of Dutch geography that was inaugurated, also known as the golden age of Netherlands cartography. And because there are competing map-making firms such as Lucas Wagner, Johan Blow, Jansonius, Claes Jensum Visser, and Frederick de Witt. So now see the Blau's world map. Blau's, originally prepared by John Blau for his Atlas Major, published in the first book of Atlas van Loon, and the Portugal by Wagner. The publication of Wagner's Die Spiegel der Welt is widely considered as one of the most important developments in the history of nautical development. So this Wagner's contribution, it is very important, particularly in the history of nautical cartography, because there are directions, very crystal clear direction he has made. French cartography. So Paris as the center of cartography. Paris. The 17th century marked the emergence of France. As I have already pointed out, one can deliver 2-3 hours lecture on the evolution of cartography, but I am trying to give an overview. Actually, it will take lots of time, but now I have come to an end in the history of or the evolution of cartography. Then I will switch over to other parts. Paris as the center of cartography. The 17th century marked the emergence of France as the center of the map trade in Europe, with much of the production and distribution of maps taking place in the capital. So from that point of view, it is very much important. It is the center of cartography, where maps were distributed, produced, and sold. Dieppe School of Cartographers. The Dieppe maps are a series of world maps produced in Dieppe, France, in the 1540s, 1550s, and 1560s. They are large hand-produced maps commissioned for wealthy and royal patrons, including Henry II of France. So, still the royal influences were there. Royal patrons, they are produced for their royal patrons. Still, royal influences were there. The modern era. So, from the ancient and medieval, now we are going through the modern era. So, using modern satellite systems and surveying techniques, contemporary cartographers are now able to measure and map with very high precision, and consistency. Now, there is cluster bombing. There is a GPS, high precision level GPS is there, or high precision satellite is there. You can make cluster bombing on a particular point, which we have witnessed during the Gulf War. And now, cluster bombing. You just focus on a particular point where you can do the cluster bombing. As a result, maps have become absolutely critical to most fields of human endeavor. So, as technology has been adopted in map making, high precision is possible, but which is gradually becoming more complex. Although all these maps prepared with the help of technology are authentic. Maps evolved significantly with the rise of geospatial technology, breaking new ground with the advent of Google Earth. Google Earth image now very common for the users. Particularly the MPhil and PhD students, they very rigorously use Google Earth image for map making. So, as digital mapping has become more popular, modern cartography tools have changed significantly. Definitely. With the advent of science and technology and with the breakthrough in the science of map making, it has I mean the modern cartography has entered into the new modern era and has changed significantly. Nowadays, map making heavily relies on computer software to develop and provide a variety of services, a trend that already started at the end of previous century. I mean, in the last 2 decades of the 20th century. Now, in the first quarter of the 21st century, we are rigorously using the software. For instance, self-location, browser search of places, business, products and area, and distance calculation. At the present time, computer-based software is dominated by big companies that offer their services to a worldwide public, such as Google Maps, Apple Maps, Bing Maps, National Geographic Maps, ESRI, I mean Geographic Info, because ESRI is considered to be the big vendor in the area of GIS and remote GIS and computer. CartoDB, Mapbox. So with the passage of time, many more software companies will come up and many more softwares we will be using for accurate map making with highest level of precision. So this is a snapshot of Google Earth image, which are widely and rigorously used by the scholars in cartography, geography, and the allied disciplines. So modern cartography tools. Little bit about modern cartography tools. Madam, can I take a break for 2 minutes?
Yes, sir.
Okay, 2 minutes only.
Yes, sir. Okay, hope all the participants have an idea that how we have started the process of map making from scratch to modern cartography. What sir is going to tell you right now.
Yes, ma'am, it is very nice overview.
Again, we'll have a session for the modern cartography related to what are the basic properties of good map, bad map. We have got a professor. He'll be joining soon at 12 o'clock from Gujrat University at 12. From 12. Gina sir, right now he has taken 2 minutes break. He'll be joining soon. Yeah, Sunil, any question?
Not question, sir.
Yeah.
But I'm really happy and I'm feeling blessed that Narayan sir has explained so well.
Still he'll be explaining. He has just taken rest.
Yes,
One
yes,
more hour you have
definitely.
left, and then you
Yes,
can.
yes.
When he will complete, please give all the good comments to Narayan sir itself. You're free.
Obviously, but
Because
I
right
couldn't
now he's
stop
not there.
myself. I couldn't stop myself,
Right
sir.
now,
That's why.
yeah. Right now he's not on the chair, so I'll be not taking his positive comments because if
Okay.
anybody is working hard for 2 hours to make you understand the subjective matter, so whenever you're putting a word of appreciation, it must be to the presenter who is taking a lot of pain
Yes,
at this age to get to you a knowledge that is free of cost at your house.
yes, sir.
And
Yes.
we that's why we as a teacher are always enforcing the student. You always will feel that why we say, go and join the sessions, do practicals, because at end
Yes,
of the
sir.
day you are the beneficiary.
Yes, sir.
You will be highly benefited. Okay, sir is back. Okay, so we'll have a discussion later on.
So coming to, can you hear me?
Yes, sir.
Yes, sir, we can hear you.
Coming to modern cartographic tools which are being used in the recent map making with high precision level, uh, uh, these can employ a huge variety of methods and tools, uh, like aerial photography, sensors, GPS, satellites, and GIS. I mean, you have separate lectures on aerial photography. You have separate lectures on sensor, GPS, and satellites. I mean, the other resource person, they will deliver it. I am just mentioning all those. Aerial photography, which I mean, have been trying to get cameras into the sky system in aerial photography. I am not going into detail. But in 1860, the oldest surviving aerial photograph was taken by James Wallace Black, tethered in a hot air balloon 2,000 feet above Boston. And modern aerial photography now relies on advanced technology like helicopters and unmanned aerial vehicles, more colloquially known as drones. Now, drone technology, you are quite familiar with the drone, which is now being used for surveillance by the administrative machinery within the country and for the surveillance I mean, it is now being used for defense purposes. Defense purpose in India, in China, and all over the world. But so far as the surveillance of the administrative machinery at different level, I mean, whether maybe at the central level, state level, or district level, drones are being used for the surveillance of the occurrence of disaster, for the surveillance of the occurrences of the turmoil, political turmoil in a particular, or racial turmoil on a particular place. Able to reach impressive heights and controlled by handheld remote, drones are fantastic tool for aerial photography. So earlier, the aerial photography, it was, but it was used at the local level. You know, drone, you cannot cover large area, but at the local level, with high precision, drone can give you a solid image of a particular place, although the coverage is lower. Though drones are still fairly expensive, the barrier to entry is low enough that organizations and even most individuals can participate. Now, I mean, the universities, particularly the Department of Geospatial Science or Geomatics, they are now introducing the course of drone technology. And many more workshops and seminars and conferences are being used, are being organized specifically devoted to drone technology. So this is a snapshot of Phantom 3 drone. Sensors. Sensors detect events, changes, and physical characteristics of a given area by transforming stimuli, I mean sound, light, heat, or motion, into electrical signals. You know that sensors send the signals, electrical signals. It is coded, decoded. There are, I mean, sensors. I mean, you know the sensors, the functions of sensors. Those signals are collected and then transmitted to the another device, usually a computer. Put simply, sensors collected data about the Earth's surface. So, I mean, seismometers. I mean, there are certain examples. I am giving the few. There are many more examples. Major ground motion, I mean, seismometers. LIDAR, 3D laser-based aerial mapping. I mean, LIDAR sensor is there, which is very much important for preparing 3D laser-based aerial mapping. Then sonar, detecting objects underwater through sound propagation. So how technology has been evolved with the passage of time and provide benefits to the stakeholders in general and society in general and stakeholders in particular. In terms of modern cartography, sensors contribute to the design and creation of detailed and high fidelity maps. So this is also a snapshot of JFAR 300-meter wind leader device. Sorry. GPS. I mean, global positioning system is a series of 24 satellites. How GPS record data that orbit Earth regularly, each transmitting the unique signal. GPS receives, intercept those signals and perform trilateration. I mean, distance-based measurement between various points, enabling a highly accurate system of navigation. So GPS actually considered to be the revolutionary device, revolutionary technology, which made a revolution in the navigation system, whether it is oceanic navigation, aerial navigation, or even GPS now it's fitted in car in the metro city. You know, even European countries and USA, GPS are fitted. When I visited this Beijing, I just told the driver the name of the hotel. So he made a program in the GPS, and the car just stopped in front of the hotel. So how much revolutionary this device is, you know? Primarily used for navigation in aircrafts, cars, boats, and mobile phones, GPS is also the primary tool for land surveying. Digital cartography has enabled the ubiquity of GPS system. Users can employ GPS to track everyday trends like traffic, mark coordinates for landmarks, chart a path from one location to another, and find their own location within a map. So this is a Trimble Geo7 axis. This is a model actually. So Trimble GPS is very, you know, very familiar for the surveyor. Satellites. Satellites serve a variety of purposes. From spying on foreign adversaries, on tracking weather and improving cell service, or as I mentioned above, now we have mobile GPS. And GPS is fit in the mobile of the, Samsung mobile, and you can do anything. I mean, mobile is all in one. There is a torch. There is you can listen music. Everything. This is all in one, and this is the blessings of satellites. You know, in terms of map making, satellites enable consistent large-scale updates of Earth surface. So I was talking about the change detection. So through traditional method, change detection was impossible because which was very hardworking and which was very time consuming also. But through satellites, you just compare the changing situation of a particular place by using the images of different time periods. Satellites have increased the speed and range at which mappable information can be collected. Surveys that once look months can now be done in minutes. This is the blessings of technology, you know. So this is used in agriculture, utilities, forestry, earth science, global change, and regional. So this is a snapshot of satellite. Geographic information system. Sensor, GPS, and satellites are methods through which we can collect data. These devices are quite advanced, and as a general rule, they lack the ability of display, organize, and manage the data they collect. GIS provides the ideal solution. So GIS is location-based software used to view, organize, visualize, and analyze geospatial data. GIS helps users wrangle their data, enabling a better understanding of positionally based patterns and relationships. Legacy of GIS platforms. Originating in the 1980s, provide tools for high-level scientific analysis and data visualization. These programs are most often desktop-based and require local installation. In the last decade, another GIS system has been introduced, which is cloud GIS system, have started to become more prevalent. Cloud GIS systems don't offer the same level of deep scientific analysis. However, they are significantly more mobile friendly, enabling users to take GIS with them wherever they go. So this is mobile GPS, cloud GIS. You can carry the cloud GIS. So this is nothing but the snapshot of a GIS layers, the first layer, second layers, and the ultimate final product is the last one. Overlaying, I mean, you are quite familiar with the overlaying of in satellite, GIS. So something about practical applications of modern cartography. We have already mentioned, but still, in a nutshell, what are the practical applications of modern cartography? Modern cartography, I mean, consider the many apps in your phone. Now, so many, but now apps have been the headache of the people. Your bank account may be zero if you download unreliable apps. How many of them rely on location-based services? Navigation apps like Google Maps, Waze, rider services like Uber or Lyft. I mean, you can book Uber. Uber can come to your home through the Google Maps. Food delivery apps like DoorDash or Zomato, whatever, all have some kind of mapping component. The modern cartography goes far beyond simply finding your location on a map. Location intelligence, 3D modeling, and real-time map creation are all based in the application of modern cartography. What is locational intelligence? It is also known as spatial intelligence. Helps users derive insights and discover meaningful relationships. So, to locate urban flooding in a particular area. Say for now, all the urban areas, particularly the mega cities in India, they are now under the grip of urban flooding during the time of monsoonal rainfall or heavy downpours. So, how many people have been affected? How many are in threat, under threat, or how many are in danger? You can locate them through locational intelligence. Locational intelligence emerged from the foundation of GIS, and it used to help organization, corporation understand positional data. You have to position. You would like to know the details of a location, of a position, which you would like to explore. Particularly, it is being used by the corporation or organization. And practical applications for locational intelligence include risk assessment, delivery optimization, price configuration, strategy development for acquisition or expansion. You would like to say you are going to distribute relief in a flood affected area. You are going to rescue a people who under the who are suffering from fire of a building. So you would like to rescue. So that locational intelligence play an important role in this region. So this is nothing but a snapshot of locational intelligence. 3D modeling. LIDAR, one of the modern cartography tools mentioned, is integral to creating 3D maps and models. And consisting of millions of individual points, point clouds are basically high detailed 3D maps. The sheer number of data points means that LIDAR scans can create 3D maps of everything from a bustling metropolis of the Grand Canyon. So we can prepare 3D modeling from the LIDAR scanner. So this is point cloud of slope failures in San Francisco Valley. How the slope has been failure that has been mapped through point cloud software, point cloud technology. Real-time mapping. Cloud technology has enabled mapping in real time. In contrast to locally installed software, cloud-based GIS platform can be accessed by any web browser. This means any device connected to the internet can be used to view and interact with a given problem. Real-time digital mapping enables an incredible number of activities. What are those? Tracking utility inspections, to watching as your Uber driver approaches the pickup spot. So real-time map making is also an important technology, applications in modern cartography. So now I have tried to compare between modern maps and early maps, because you cannot deny, I have already deliberated, I have already pointed out before you that you cannot ignore the early maps, because early maps were the foundation for the modern maps. So, but what are the advantages of modern maps over the early maps? So early maps depicted small areas, a city, trade route, hunting ground, military campaign, were pictorial in nature. It was painted in caps and walls, whatever, while they look crude compared to modern maps. Now, modern cartography has given you the sophisticated look. When I have done my PhD, I have prepared all the maps. Personally, I have not used GIS software, but that time I have done my PhD at in the middle of 90s. So that time this GIS software were not available to everybody, So now you can produce a colorful map, a sophisticated map with the accuracy of high precision level. The relationship between features on the map and reality on the earth was not accurate. For example, features in the center of the map would be shown in great detail, but features closer to the map edges are much more basic. In many cases, where works at first sight, reference documents, second part of the reason for this is the maps were made by hand, were expensive to make, and earlier maps, the traditional maps, which are very coarse, which are very, time consuming and very expensive also. But now in a minute you can produce a map. So now I am coming to the second part, map classification. Oh, 30 minutes left, I don't know. So I have to move fast. Actually, the evolution or the history of cartography, it took much time, But I think you have enjoyed a lot.
Sir, Sunil wants to add something. Sunil?
Yeah.
Yeah, please, sir. This Sunil had some comments for you. He wants to say something. Sunil.
Okay.
In between.
Sir,
Yeah.
Let me finish.
Sir, Narayan, sir, my name is Sunil, and I am studying my MPhil in geoinformatics under the supervision of Suraj sir and Shruti Kanga ma'am. Sir, though I have some experience in GIS field, I feel that the kind of information you shared, that is just not common, sir. Like even in the studies, we study maps, okay, some old age maps, recent maps, and early mapping technology and what we have today. But the way you explain things, that is not going to be taught anywhere other than you, sir. This is I feel about you, and yeah, I hope if I could meet you personally somewhere in life, I would be delighted to have you along with me, sir. And the information you shared, specifically the historical maps, even before the standard era began, that time the mapping system, how it was available, whatever technology they used, and how they evaluate all the mapping systems and everything today we are seeing. Uh, the way you started and you put every step just by the way that era was coming to the recent time, That was so amazing, sir. I just felt the roller coaster ride since the inception of the mapping till date. So I don't know how I am keeping my word for you because I'm feeling so overwhelming to attend your class, sir.
Okay, I mean, I am overwhelmed by your comment. I am not that much GIS expert like you because you are dealing with the GIS, but I have tried my level best to give a comprehensive view of the digital.
सर कभी होता है
Sir.
सर कभी कभी होता है कि एक्सपेक्टेशन से ऊपर की चीजें बताना और कभी होता है कि जस्ट टेलिंग द एक्सपेक्टेड थिंग आई वाज व्हेन यू स्टार्टेड आई एक्सपेक्टेड समथिंग अनयूजुअल फ्रॉम यू एंड यू एग्जैक्टली डिड दैट सर
Okay,
सो थैंक्स फॉर
okay, thank you.
Sir, 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 even I want to say that whatever GIS or digital cartography we are talking about, it is the outcome of traditional cartography. Without that, we could not have reached on this point. Now also, whatever modeling we are talking, whatever things we are talking, without the complete mapping, it's incomplete, I can say, without a good representation of map. So behind any technique, whatever modeling, whatever things we are talking about, without the concept of cartography, the map making thing, that is incomplete. So sir, we had a very good outcome, whatever you have delivered today.
How it has been
Yes.
evolved. So let me finish the deliberation. Map classification. So I am moving fast. According to ICSM, I mean Intergovernmental Committee on Surveying and Mapping, there are 5 different types of maps: general reference map, topographical maps, thematic maps, navigational charts, and cadastral maps and plans. So what are those? General reference map. I mean, you are quite familiar with the general reference map, where cities and towns are named, major transport routes are included, along with natural features like lakes, rivers, mountains, or whatever. So these are general maps, and they tend to be easy to read and include street and tourist maps. And we can think of many better examples of than here maps. So topographical maps, you're quite familiar. I mean, particularly the GIS specialists, they digitize the topographical map. They know the geography and non-geography people also. They know the topographical map. And this topographical map, it gives you a detailed elevation with contour lines, helping to map the landscape. And ordnance survey maps are arguably the best known type of topographical map. That means, topographical maps in India, which is produced by the Survey of India, the traditional one. Now it is modified. It is getting modified. If I am not wrong, the topographical maps, the conventional topographical maps are now getting modified, putting satellite images of that particular area. But thousands of other map makers have created detailed alternatives. Even if you cannot see specific landmark, left or not, for example, it is possible to work out our exact location by following the contours and checking out the landscape around you. So this is a typical late 20th century general reference map of a country. So it is a map of Australia. I mean, like India, every country is a general reference map. It is colorful. Cities are named. Major transport routes, I mean highways and railways are identified. Natural features such as rivers, lakes, and mountains are named. Elevation is shown using the simple color shading and has themes included. City population size has also included in this general reference map. This is nothing but an extract of a topographical map with the scale of 1:50,000 scale map. Annotated in pink to highlight the different landscape features which can be identified using the color lines. This map had a contour interval of 20 meters. So we are quite familiar with a topographical map of 1:50,000. And thematic map. This is basically devoted to themes. The map basically devoted to themes. I mean, themes are getting emphasized with this map. And it could be anything from geology to population density or weather. And the companies like ESRI use thematic maps to make a massive difference to business, governments, and other organizations around the world. Navigational charts. So, along with the general reference and topographical maps, navigational charts are another invaluable tool when it comes to actually getting around, whether you are at sea or in the air. So it is very important. I mean, navigational charts has a vital role to play in navigation. Maps are for the oceans are typically referred to as charts, and the same applies to air navigation maps. The charts tend to include information that's important to avoiding accidents, such as features in and around the water, like submerged rocks, along with any specific navigational aids. So this is the snapshot of thematic map. This is a map of Australia's black coal exports between during 1985-86. A typical stylish thematic map where the map itself is secondary to the information being supplied. The intent is to quickly give an impression of relative differences and the detail being supplied as tables within the map. So, I mean, the theme has been put in the Australia with some description, direction and description with both. So this is an extract from Australia charts, which cover part of Indian Ocean and include Ashmore Reef and marine navigation charts. This is cadastral and maps and plans. I mean, all of you, those who are from rural background, and most of us from rural background, we are living in the city, but we are quite familiar with the cadastral maps. The Mauja map, even popularly known as Mauja map, you know, you will find the Mauja map at the local level. So it's lot more specific, and although they are widely used, there is good chance to see every day. Each and everybody, those who are those who hail from the rural background or rural area, they have definitely seen the cadastral maps. So this is a snapshot of cadastral maps, and the red mark portion is a cadastral plan. So if you put cadastral plan together, then it will be a cadastral map. Map elements. Some of the essential elements of map are title, direction, legend, north arrows, distance, levels, grid and index, citation. So title, every map should have a title. I mean, clear-cut title, you know. The title should be self-explanatory. अब title पढ़ेंगे तो सब पता चलेगा. I mean, it will give you a first-hand view of the map. It is the keyword that grabs the reader's attention. And the need for a suitable title, whether small or long, depends on the reader, but the title should provide an answer to the what, where, and when. It should be self-explanatory, which I have already pointed out. Direction. Direction is shown on a map by using a compass rod. I mean, north line. You know, the compass rod shows the directions on the map so that map readers can relate those directions to the real world. Legend. There should be, if it is a thematic map or whatever, there should be a legend. The principal reference to the map symbols subordinated to the title and direction. However, this is still the key element for map reading, describing all unknown or unique map symbols. So actually, we use in a map legend and index. So when it is expressed quantitatively, it is index. So far as I know, if I am not wrong, and if it is color notation, then it is legend. You know, I mean qualitative expression. North arrows. North arrows indicate the orientation of the map. Maintain a connection to the data frame. We put north arrow line. Distance or scale must always be indicated, whether it is in kilometer or mile, inch to mile, centimeter to kilometer, whatever. It is sometimes it is in representative fraction, sometimes it is in linear scale. And distance and scale can be indicated in a variety of ways on a map, in verbal, numeric, graphic form. So you can put 1 centimeter to 2 kilometer. So 1 centimeter to 2 kilometer you can graphically represent. Levels are the words that identify location. They show places, street, rivers, and establishment. You just put level to the features which are shown in the map, with specific names, and can also be used to represent something. If there is only one of it, instead of mapping, grid and index. Not all maps use grid or index, but it really helps in finding locations. A grid and index are common in atlas and on road maps. So there should be a grid, for example, in atlas or road maps. The index is mainly in alphabetic order that makes it easy to look up to the name of the place. There are coordinates next to the location of the A2, B3, like that. Citation. The citation portion of a map constitutes the metadata of the map. This is the area where explanatory data about the data sources and currency, projection, information of any caveats are placed. Citation helps the viewer determine the use of map for their own purpose. Now there are certain checklists how to create standard maps. I am not going into detail. I am just mentioning the points only. Map has a clear purpose. Map title reflects the author's intention. Use the appropriate template. Add company and client logo. Ensure correct map extent and coverage. Define a projection. I mean for like atlas or transport map. Or display the correct content. Give perspective with an inset map. Suppose there is a map, India map. Inset map, like when we put location map in our PhD thesis or a project report, suppose for India, in India, we have given the insight map. I pointed out the Rajasthan map. Then from Rajasthan, then arrow for detailed Rajasthan. Then in Rajasthan, we put an inset mark in Jaipur, then the detailed map of Jaipur, like that. You are quite familiar, those who are research scholars. Key map, a map within map. Decide your leveling or annotation. Glue readers, I mean readers and neat line. Neat line just paste with the neat line. Order layers by importance. View all ingredients in your map with legends. Measure length with scale bars. Know that, I mean, there were certain figures I did not put here because due to time constraint. Know the date of production. Metadata is your map's narrator. Orientate yourself with the north arrow. Fill in the surrounding map data. Cover yourself with the appropriate disclaimer. Fill out data source information. Add graticules as handy guiding lines. Ensure standard symbology is used. Use appropriate scale symbology. Select colors that reflect a theme and purpose. Think outside the box with different map types. Carefully select typeface. I mean the font and the style, Times New Roman, bold or italics or whatever. Because you know, a production of map with all the themes, legends, typeface, that would be a legible one. That would give you a synoptic view and the most panoramic view of a map. Italicize water features, be aware of the overlapping text, carve out the authors and reviewers' name to the map, run a spell check, features in legend are present and singular, find balance and harmony. Principles of map design. I think this is the last part of my deliberation. So hope I will be able to finish by 12. So there are 5 principles, you know. One is visual contrast, legibility, visual contrast, figure ground, hierarchical organization, and balance. Together, these form a system for seeing and understanding the relative importance of the content in the map and on the page. Without this, map-based communication will fail. Together, visual contrast and legibility provide the basis for seeing the contents of the map. Figure ground, hierarchical organization, and balance lead the map reader through the contents to determine the importance of things and all visual contrast. What is visual contrast actually? Visual contrast, I mean, the figure will clear the visual contrast. Visual contrast relates how map features and page elements contrast with each other and their background. The concept of visual contrast also applies in cartography. A well-designed map with a high degree of visual contrast can result in a crisp, clean, and sharp-looking map. See the map. Although black and white, figure A provides the best visual contrast. But see, B is, this is not always the best color combination. And B, when using color or similar, high B or low C saturation brightness. But I mean, visually, A is good, B is poor, C is poor, but going to D, it is a little bit good. And if you go to E, it is good, and the and F also, these are also good. I mean, visually these are good. So the map visualization, I mean, visual contrast is important in map. Legibility. Legibility is nothing but the ability to be seen and understood. You can see the map easily and you can understand also. Many people try to make their map contents and page elements easily seen. But it is also important that they can be understood. Legibility depends on good decision making when selecting symbols. Choosing symbols that are familiar and are appropriate sizes results in symbols that are effortlessly seen and easily understood. So see the legibility. Symbols A and text C that are too small are illegible. I mean, it is symbols in A and text in C are illegible. These are very difficult to understand. Appropriately sized symbols, I mean B. Symbols are very legible in B and text in D can be easily distinguished and read. So this is the legibility. If you see the map, whether it is legible from the symbol point of view or text point of view.
Both.
Now the figure ground organization. Figure ground organization is the spontaneous separation of the figure in the foreground from an amorphous background. So figure, you look the figure in the foreground, but there is a background in the figure. So there should be a legibility. Figure ground organization. Whether I mean, the background should be such that the foreground figure should be understood very clearly. Cartographers use this design principle to help map readers focus on a specific area of a map. So, switching over to the figure, see, it is sometimes hard to tell what is the figure and what is the ground. A and B. ए एंड बी आप देखिए उसमें कौन सा फिगर है, कौन सा फिगर और कौन सा बैकग्राउंड, कौन सा फोरग्राउंड, कुछ पता नहीं चल रहा है. इट इज वेरी डिफिकल्ट टू अंडरस्टैंड. Simply adding detail to the map, C, can help map readers distinguish the figure from the ground. Within map there is text and background is white, and you put certain color marks in the map and background is little bit hazy. So that means you are giving much more importance to the foreground figure. And you see, the using a whitewash and feathering or a drop shadow can also help. I mean, if you put whitewash in the background, the foreground figure will be dominant, as in case of E and F. Hierarchical organization. This is the internal internal graphic structuring of the map, and more generally, the page layout is fundamental to helping people on the road map. The visual layering of information within the map and on the page helps readers to focus on what is important and lets them identify patterns. The hierarchical organization of reference maps, those that show the location of a variety of physical and cultural features, such as terrain, roads, boundaries, and settlements, works differently than for thematic maps, those that concentrate on the distribution of single attributes. That means hierarchical organizations mean the priority to which features you are giving priority. See, when the symbols and labels are on the same visual plane, it is difficult for the map reader to distinguish among them and determine which are more important. For a general reference map, B, using different sizes for the text and symbols, for example, city points and labels, different line styles, for example, administrative boundaries, and different line weights, for example, rivers. So some of the ways you can add a hierarchy to the map. So you have to put emphasis, you have to prioritize which one you want to give emphasis, so that it should be crystal clear. When mapping thematic data, I mean the map C, the base information, for example, when mapping thematic data, the base information, for example, county boundaries and county seats, should be kept to a minimum so that the theme, for example, soil, is at the highest visual level in the hierarchy. So the theme which you are giving much more emphasis, that should be highlighted. This is the hierarchy. But all other informations will be there. But the theme you would like to highlight, that should be you would like to emphasize, that should be highlighted. Balance involves the organization of the map and other elements on the page. So balance is nothing but the final, whenever you are going to take a final output of a map, so there should be a balance. There should be a balance in the foreground, background color, foreground color, text, labeling, then annotation, everything. There should be a balance. I mean, this should look nice and a good piece of product. The well-balanced map results in an impression of equilibrium and harmony. You can also use balance in different ways to promote edginess or tension or create an impression. So the first-hand appearance of the map will be map. Oh, it's good. It's look nice. That means crystal clear. Legends are very clear. Text are clear. Background color and in adjustment with the background, the foreground color is also looks good. Together, these 5 design principles have a significant impact on your map. I mean, this is, I have already pointed out that all those points should, there should be a balance between those points. Figure. Positioning heavier elements together can make the page look top heavy, see A, or bottom heavy B. Centering the map slightly above center, that it is in the most prominent position on the page. The position of elements can also cause the eye to move in a desired direction. In D, the title is the first thing read, followed by the locator map, then the map of Africa, finally the region. So, I mean, it is nothing but the balance of all the principles of map design. So now I have come to the flag end of my deliberation, and I am lucky that I am going to end this lecture because I have one important meeting. I cannot take part in the discussion. Maybe 2-3 minutes I can take, but not more than that. Concluding remarks. Cartography is a rich subject with deep historical roots that Madam has clearly pointed out. I mean, now the remote sensing, GIS, the GPS, we are all exposed to the modern technology tools, but all the technology which are significantly contributing to the modern map making, that should acknowledge the historical development of cartography, or it is deep rooted in the historical past. I mean, the map produced through GIS technique is as important as the map prepared by a sailor, by a cartographer in the stone wall or cave painting. It is important. Modern cartography stands on a foundation that dates back millennia and continues to grow and evolve with each passing year. So the technology is very fast. Now 3G, 4G, 5G, so there are so many G, you know. I mean, if you purchase one mobile of 4G, now 5G are coming. 5G we have already maybe, and after 1 or 2 years you will have the 6G. So how many mobile you will purchase? So there is a fast development of technology, you know, with data from drones, satellites and sensors, plus the robust capabilities of GIS mapping software. The future of cartography promises to be bright. Definitely, we all now are heavily relied on the modern cartography, specifically GIS mapping software. It is not merely the sole discipline of geographers or the earth scientists. I mean, GIS technique, remote sensing technique, I mean, it is, I mean, people are experts from all disciplines, particularly, I mean, science. Even in population, you know, the Registrar General of India office, they are using GIS for their population map. It is not like that social science people, they do not use GIS, but they use GIS. I mean, the history people, I mean, one history faculty came to me for a number of maps. He will be using in his book. So now GIS and the modern cartographic tools has penetrated into all the disciplines, whatever may be the nature, whether it is social science discipline or the science discipline, whatever it is, it has penetrated to the doorstep of all the stakeholders. Thank you all.
Thank you so much, sir. Thank you.
Thank you, sir.
I don't know whether
Thank you so much.
I have been able to meet your expectation, but I have tried my level.
Sir, more than expectations, sir. It was very good session. Thank you, sir.
I think
Thank you for your enlightening and in-depth presentation on the history, evolution, and the importance of elements of map making within such limited time. And we can't thank you enough for having this area clarified in such an comprehensive way, because without having such in-depth knowledge we cannot learn modern day ways of mapping. And I consider myself very fortunate enough to have this lifetime opportunity to learn so much from you, and looking forward to learn from you in future too. We owe you a sincere thanks and for being here and have taken time to enlighten us from your busy schedule. Really appreciate that. Thank you once again, sir.
so. I mean, I would like to request all the participants to come on video mode so that I can take one, two snapshots, screenshots.
Turn on your cameras.
Yeah, on video mode so that I can take a screenshot. Thank you.
Thank you,
Thank you,
sir.
sir.
Thank you so
Thank you,
much.
sir.
Thank you, sir.
Namaste.
Thank you so much,
Thanks
sir.
a lot. Thank you, sir.
राजस्थान में क्या अच्छा मिलता है बेटा?
सर
सर
घेवर घेवर मिलता है सर, बढ़िया।
मैंने जयपुर से घेवर मेरे बेटी के लिए।
हाँ जी
सर, हम भेजेंगे।
हम भेजेंगे। और सर आपका सर हम लोग वेलकम करते हैं जयपुर में सर। आप जब भी आए कोरोना के बाद तो फिर ज्ञान विहार में हम लोग पूरा होस्ट करेंगे सर आपका सारा चीज। ये हम लोग का आशीर्वाद चाहिए आपसे।
And I have placed order for घेवर. They have sent me by courier.
ठीक है सर,
लक्ष्मी
ठीक है सर।
भंडार LMB राजस्थान नो।
हाँ जी सर। सर दाल बाटी भी है सर, दाल बाटी चूरमा।
हाँ, दाल बाटी चूरमा। Dal bati churma I cherished when I have visited this university.
Rajasthan University.
Banastali Vidyapit.
Okay.
Banastali Vidyapit, where IIG meet was there, and dal bati churma I cherished. But I cherished much घेवर.
Yes sir.
Okay.
हाँ जी सर।
Thank you all the participants and thank you Shruti ji.
Thank you, sir. Thank you so much. That all the candidates, including me, have learned a lot from your lecture. It was from the scratch to drones and everything you have covered, sir. Such a informative and deep lecture. I have learned a lot. Thank you so much.
Thank you. Thank you. Thank you.
Thank you, sir.
Thank you sir. Thank you sir.
Thank you, sir. Thank you. Take care, sir.
Now we'll move forward. Now I ask Miss Upasana Chaudhary to invite our next speaker.
Moving ahead, now I would like to introduce to our next speaker, Dr. Ajoy Das sir. Dr. Ajoy Das sir is currently working as a cartographer in Department of Earth Science, School of Sciences, Gujrat University. He has completed his PhD in Geography, Wetland Ecological Diversity of Kutch District, Gujarat, from Gujrat University, and his MTech in GIS with specialization in biodiversity conservation and management from NIIT University, and PG diploma in geoinformatics with specialization in water resource conservation and management, MA in geography with a specialization in agricultural geography from CSJM University Kanpur, and BA in geography with specialization in soil science from the University of Burdwan, West Bengal. He had published many research articles papers on national and international platform and received awards and prizes. He had attended many training programs on hydrological modeling, GNSS, microwave remote sensing at both national and international level, and received scholarship and fellowship. He had expertise on research and training, cartography, GIS, remote sensing, climate change, photogrammetry, DRR, and advanced field techniques from last 9 years. His working areas are natural resource conservation and management, biodiversity conservation, terrain analysis, disaster management, and risk assessment, and spatio-temporal modeling addresses critical and temporary issues. He is always ready to work in field-based research with various geophysical instruments. So we are very delighted to have you here and would welcome you for your training session. Thank you, sir.
Thank you so much, Upasana, and I want to thank Professor Suraj Singh sir and Dr. Shruti Kanga madam for giving this opportunity to me, and it is my humble pleasure to give to share the knowledge with all of you. And also I would like to give thanks to Suraj Gandhia University and team Geoinformatics for this opportunity. Okay, so let me know. I don't know the level of the students that which are the backgrounds from you.
They're beginners, interdisciplinary beginners.
Okay. So multidisciplinary, right? On geography, the major subject background.
Geography and GIS.
Geography and GIS, right? Okay. Thank you, sir. So I had given the topic, so I am planning to share the slide, right? Okay. Now, is it visible to all of you?
Open the slides.
Yeah, just a minute. Now, is it visible?
Slideshow mode. Let me see.
Okay. I will. It is visible now, right? Right.
Yeah.
Okay, good. So from the last lecture, Dr. Narayan Jana sir has given all the things regarding the cartography, and as per my profession, I am the cartographer. So it is very difficult to describe all the things in a 1 hour lecture, but I will try to give my best. Okay, see, I will focus on the analysis of good and bad maps with reasons, right? So is there any problem for hearing? Sound is clear, right?
Yes.
All good, sir, all good.
Okay, done. So I will cover the analysis of good and bad maps with reasons, right? Map, for a composition of map, you need to focus some component or some elements that will combine the whole things and display the matter you want to show. So first of all, I want to ask all of you that everybody knows that scale, reference system, and the coordinate systems, right? Participants?
Yes, sir.
All of you know, right? You are the geography students and GIS students, so there will be no problem.
Yes, sir.
So I will skip some of them. Basic that I will skip, but what we will focus on, I will show you, right? So for a map composition system, you have to focus on first you have to focus on scale and the reference and the coordinate system. Now, right now, so what you have to know, because the terms you have to familiar with this. The map scale, when you are talking about the scales, you have to focus on the map scale and the representative fraction. It is also important in the for a map, and verbal statement of a scale that should be also in the that should be on the map, and graphical scales, reference systems, coordinate system, and geographic coordinates, and Cartesian coordinates, and UTM. UTM is the projection system. So these are the projection systems: coordinate system, geographic coordinate system, and Cartesian coordinate, and the UTM. So these terms we have to focus on. Now, what is map scale? Map scale is a ratio or proportion between measurement on the map and those on the earth, and the scale is what measurement is showing in the map. It is how much it is equivalent into the ground. So this is the main thing, and we have to know that the scale is an average across the map and is based on where the distortions will be least. Some indication of scale must be included on any map. Now, these are the general things. I will focus on only, three ways of communicating scale, that is representative fraction, and the verbal statement, and the graphical statements, right? So now these are the calculations. You know very well that how the map units are converted into the ground scenarios. So I am skipping because these are the basic things. 6 inches. Yeah. So graphic and per scale, how it is represents, you know, this graphical scale is showing that this centimeter, or if it is in inches, whatever, it is showing the 20 kilometers, right? This distance is showing the 20 kilometers, and this also showing 20 kilometers. So these are the parameters of showing the scale in different way. This is one way, this is one way, this is one way. These are the graphical statements, graphical scales. So graphical scales, you can use any one of the design. These are the designs basically, and the categories, how it is categorized by different units. So many people assume that the units are in inches, not always in the case. So inches and the centimeters, it will depend on you, how you want to publish or how you want to show in the map. Now I want to skip this. This is how to calculate the RF, representative fraction, mean distance and ground distance, map distance divided by ground distance. You know all that. I want to only skip. Okay, so this way, the paper strip of a geographic scale trick, you know, this way we had calculated the radius line and the boundaries of an area or a wetland, or you may have a forest area. This way we are calculating. So with the help of a strip and marking them to the contour lines and plot into the plain paper. How it is showing. So these are the bigger range, how it will define by the scales, vertical scales and the horizontal scales, right? So new features like that, you know, in the sense it is not visible clearly, but you can see it is on the link given, not an issue. So I will just skip. Yes. So some common map scale round numbers make it life easier. So 1:24, 1:50, 1:100,000, 62,000, 63,000, 360. What it is defining? Can you tell me that what is the difference between a 24,000 map and a 1,000? That means 1 million map.
Solve 1 million map is small scale and 1:24,000 is large scale map.
Large scale and small scale, right? So the difference is main difference is, what is the main difference between the large scale and the small scale? Anyone?
Large scale map will show more information but covers smaller area, and
Yes.
smaller scale map covers larger area but shows little information.
Okay, so the small scale maps will give you less information regarding from a wider area, and large scale map will give you more information with a smaller area, right? So what will be the accuracy of for both the maps? Which will be better, large scale map or the small scale map?
Large scale map, sir.
Sir, depends on our purpose, no?
Yeah, I think it depends on our work, right? So if I say that I want to work with a block level or taluka level study, so which will be the better, small scale
So
or
large scale.
large
Large
scale?
scale, sir. Yes, sir.
Okay, so block level study that will prefer the large scale map, that is 1:24, or you may define as per your study. It may be 1:10,000, 50,000 as per your requirement, right? And when we are working with the scale, that is a small scale map, small scale map, that is 1 million map. So there we will get so small scale map in which level we will use this, state level or country level, which one?
So country level, 1
Country
million.
level, country level,
State
district
level.
level. Yes, district level, country level, we may use 100 or 50,000 map, right? So it depends on the study area. So depends on the total study area. It may be 2 districts or 3 districts, then we may use 100,000 scale, and if we have 1 district for a study, then we will use 50,000 map, right? Okay, so next, these are not requirement for this now. Okay, and now I will skip to another presentation. So the map element where Jana sir has left, right? Okay, now, so map elements, how they interlinked, right? Now, how to, so from this presentation, we will understand how to use maps, globes, and other geographic representations, tools, and technologies to acquire, process, and report information from a spatial perspective, right? Why we are composing map? Anyone can tell me why? What is the requirement for a composing a map? Why we are doing mapping? Why map is required? Please tell me, anyone?
Sir, to understand clearly everything about the earth.
Okay.
So to see the arrangement of the facilities and the organization of the buildings or feature available there.
Now, one more thing. Is it required that we should prepare a proper software based एकदम perfect map जिसको बोला जाता है कि you know the proper with proper color set, with proper attributes, with proper elements in a map, we should require, or we may use some map which will be composing with the help of some information from the villagers, from our natives, from our neighbors. That is that is called like mental mind mapping. You know, mind map. Do you
Cadastral map, sir.
No, that is not cadastral map. I am talking about the mind map. Okay. Do you have any idea about the mind map?
Yes, sir.
So, what are the difference between mind map and a regular map?
Sir, mind map is not that accurate. Then proper map is more accurate and displays more information.
Okay, so why it is not accurate?
Because maybe we can say the mind map is the perception sometimes, and actual maps is belongs to the reality of the ground of that particular area.
Okay, so with the particular whatever we are drawing on a simple plane of paper, that is maybe on a it is also reality based, because what are the really exist in the ground, existing on the ground, we are plotting on it onto the paper, right? So if we are taking from a help from any other sources, and if we are taking help from some human being living with us, so what are the main difference between those parameters? You are taking real information from them and you are plotting, right? On a you are sketching, right? You are taking a piece of paper and sketching all the information onto the paper. And one another way, you are taking information from some of the base maps, right? Base map, that means that should be a satellite imagery or maybe a topo sheet, maybe a cadastral sheet, whatever. So what will be the main difference? Both have the accurate distance. Both map has the similar informations and exact informations. But what are the main difference between two maps? If you map the total information into a calculative manner, and another way you are plotting everything on a imagination based. Both the information are true, but what are the main difference? Anyone can?
Sir, I guess accuracy.
Yes, accuracy. Because when we are preparing a mental map, a mind map, there is no calculative approach. There is only imagination. What kind of? That if I say, just you can you draw a map where when you are going to your college or university to attend your class, just prepare a map, your all the activities. Because it will take 1 or 2 hour or maybe 30 minutes, whatever. If you are staying in hostel, then it will take 10 minutes or 15 minutes, but it has many stages. So if I ask to plan and plot all the data into the map, then you may try for that. So when you are mapping all the stages, when you wake up and after wake up you take right or left, and you come to the bus stand and you take bus, and when you drop off from a bus and then taken left. So this way you are planning and plotting all the data. And another way, you are taking help from from a base map, right? So both the information, one is mentally information, and one the imaginary information, and one the basic information already defined by someone else, right? So the accuracy in imaginary map, you can just assume that these are the information, and from this information you can go anywhere. If the information taken by someone else, and if he or she follow the instruction, whatever you drawn on the piece of paper, he also arrive to the destination. And from the other map, if no one help you, no one give you any information, but if you have a base map, then through the direction you will go to the go to your destination, right? So this way, so the basic thing is the calculation. So how we plotting the data into the map, based on calculation or based on imaginary? Now, so from the map elements, you know the latitude, longitude, and the hemisphere, direction, time zone, scale, and map legends. These are the necessary elements for a map. And for paragraph, we will just skipping, because yeah, latitude and longitude. The Earth is divided into lots of lines called latitude and longitude. You all know South Pole, North Pole. It is not required to discuss again. Longitude lines, you know all the things, but I will focus on another thing. Where is 0 degree? You know the equator is 0 degree latitude, and it is an imaginary line that runs half point. That's why I'm talking about the imaginary line at the mind mapping. So 0 degree prime meridian, you all know that because you are the geography student. So now the world. Is it the real shape of the world? Anyone can tell me?
No, sir.
No, sir. No, sir.
It is calculated shape.
It is calculated, right? And how it is calculated? It has it is followed by some calculations, or it is followed by some principles. Do you have
it is on cylindrical projection?
Projection, that means a projected surface, right? We had projected all the land masses available to, as we know, the Earth, and plotted into piece of paper with the help of some imaginary lines, right? These lines are drawn. drawn on the Earth surface?
That's imaginary line.
These are the imaginary lines, like our mental map, right? जब मैंने कहा कि आप कॉलेज से आप घर से या हॉस्टल से आप यूनिवर्सिटी आ रहे हो या तो आपके डिपार्टमेंट में आ रहे हो तो आपने कौन से स्टेप फॉलो किया, कहाँ पे उतरे, कौन से डायरेक्शन में आपने मूव किया. So your movement also you plotted in your paper and you draw a map. That is called the mental map. Here it is also a mental map, right? Because these are the imaginary lines. But the main thing is the imaginary lines and the calculation both combining with a piece of paper, and that is represented to you as a global map, right? Here is also an imaginary line and also a calculative manner. So there is also calculations as per the Earth surface radius and all those things, and the angle of elevation. Each of things are calculated by this. So and the output is like that. Okay. So now. No, it is hemisphere, western, eastern. No required because it's this presentation for the basic trainers. Compass we don't need, direction and scale, maps, right. This here it is one kind of one map is given here for a Tennessee. Represent the Earth and so a map of towns, would mile long strip and following auto. This is a this highlighted area is a city boundary, right? And one river is going through this way. So the main purpose of this, we are demarcating one city, one state, I think. One state, one city area, like the Tennessee, UG, like this, and we're highlighted this, and we have given the already legends in there, the native populations. But in this map, you will see each and everything is there. You may find the scales and the proper projection. You have here. It is not mentioned that what kind of projection is used for this kind of map, but the other elements are given there. Okay, so next we will focus that these are the scales and how it is mentioned. Now time zones, we will set different time zones for different states, right? Pacific, Mountain, Central, United States. There are four types of time zone for their working experience. And map legends. These are the legend is the key to the unlocking the secret of a map. Yeah, you know all that. But the location of the legend you should prefer on the map. How we will plot all the legends and how we will show the map that is a good looking map or bad looking map. Here it is. You may say that it is a good map or bad map. We can say the bad map. It is drawn by a right way or wrong way. Is it okay? This map?
Not at all, sir.
Is it okay?
No, sir.
If I say that is this a right map? Just a minute. Okay. So because there is no heading what this map is showing, but there is legend, and there is no scale is given also, and the direction has not been given also, and the projection system has been used for plotting these elements to the map, that is also not mentioned here. So we can say that it is a good map followed by all the cartographic rules. So next we will go and we'll see religions and legends both, and the next map. Here it is, the title is given, use of land in Tennessee, how it is used. It's a land cover map. Land is land cover, and the information the legend has also given. Is it a map or something else? Can I call it is a map? Because it has many informations, and it has a boundary, it has a look also good looking, and with based on some different colors also. So can you say it is a map?
No, sir.
No, sir.
Why?
No
No, sir.
scale, no direction,
scale,
sir.
no direction, no lat long available there.
Right, it has no direction. So from there we can say that which direction is north, which is south, we can't say. And another thing is that in which scale it is the map is showing you in which scale, right?
But lat long not available to show
And
the
the
location.
most important thing, that is the lat long. Why we need the one I have one questions on that. Why we need lat long? If we don't have any lat long, so there will be any problem
Yes, sir, to find the location.
to find out the location, right? So why the location is needed? I'm standing here, it is my location, and that is this, and that's it. I can say I'm in the land surface.
Yes, sir, but uh, Earth, Earth location is a 180 and 360, so where we lie on that portion of the Earth that represented by the location lat
But
long.
when on the Earth's surface to know that we need.
Yeah. And any other information? Why we need the lat long? Because we know
Sir, to
if
get
I
a accurate location,
for our accurate location in
exact location.
exact location
Yes,
Yes,
sir.
sir, exact location on the Earth, or precise location on the Earth.
on the earth, right? On the globe, because we are living on in the globe, right?
Yes, sir.
In the globe or outer surface of the earth.
On the surface of the
So
earth.
whatever it is, but the main thing is that if we want to locate ourselves or myself, that in which place I am living in or which place I am standing in. So that is more important, because if I say that I am in Gujrat University. So if I say I am in Gujarat University, someone if someone hear this, and he will assume that where it
Sir,
is.
it is related to a reference point, mainly reference.
Okay. So from the assumption, or from his assumption, he will locate myself that okay, he is in Gujarat. So Gujarat will be the western part of India, and it is located near about the Arabian Sea. Okay. So you can assume. But if I give you the exact point that is combined by the latitude and longitude, then you can easily identify me from any remote or from any part of the world. You can access me, or you can locate me, right? So with the help of latitude and longitude, you can justify each and every information on the earth surface and anywhere of the world. So that is the importance of latitude and longitude. So here it is not mentioned the where is the latitude longitude, and this information is now useless, right? If each and every information have no latitude longitude, then it is baseless. We can't justify or we can't identify them where they are, though the city name is mentioned already, right? And if we say the previous map, this one, Tennessee, right? This map is showing in a larger way, in this way. But all the information is given is here, but we are missing all the information due to lack of the latitude and longitude. So we can identify their location, exact location where they are living in. Though all the things are given and plotted easily, but in a map it is also required. So if without latitude longitude you are preparing a map, then it is baseless and it is useless map. Okay, now age expectancy, we don't need legend. Yes, it is right to visit. These are the maps. And now another thing, I will give you some expedition on. Now the main theme is like that, right? Okay, the projection system, why it is happening, right? This is the most important thing. What I'm saying, that If I want to locate someone, if I want to identify some person in the globe, then I have to calculate his or her location as per the spheroid shape of the earth. So there is a different kind of projection is already invented by many cartographers, many scientists, many geoscientists, and they had calculated, many mathematicians has calculated and invented many kind of projection systems to plot the earth or to plot the land masses on the land masses available in the earth surface. How? The earth is a spheroid. The best model of the earth is a globe, right? It is looking that. Not too easy to carry. You can't carry this shape in all the point all your study, and not good for making planimetric measurement, that is distance, area, angle. It is very difficult. If you want to measure this portion, so you can put a scale and measure this and measure this. But when you go to the reality, you will find something else. Is it real? Anyone went to field for any observation? Anyone have any experience? Hello? Hello? Am I audible? Audible?
Yes, sir. Yes, sir.
जी सर, जी सर।
सब सो गए थे क्या? अच्छा, ये समझ में आ रहा है ना? नहीं तो
Yes, sir.
हाँ सर, कोई गया नहीं है
I'm
लग रहा
not
है।
getting response. Okay, no problem.
फील्ड ट्रिप नहीं गया है।
Okay, it is not this arrangement is not good due to lack of time, because I today I know that I have to take a one lecture, so that's why I'm taking from there. It is puzzling you. So the proper arrangement is required for a particular lecture. Oh, okay, not a problem. But I will focus on the projection and scale. I already that's why I skipped, because you all know the graphical scale, linear scale, vertical scale, whatever. So that's why I had not focused. I have only 20 minutes. So within 20 minutes, I will try to complete the projection, because projection is the main thing which will tell you the exact location of your positions. Now, okay. So maps are flat and easy to carry, good for measurement and scalable. These are the main functionality of a maps. Right. So this is one of a geological map. Here I had used for as an example. This map has latitude, longitude also. You'll find these are the latitude, longitude. Here it is mentioned, right? And each and every elements represent here. It is based on the calculations. So as per the projection, you will whatever information you want to get, you can go and put a point and calculate them, and you will get the exact location of the element anytime, right? So the way previously many of our scientists and many of our cartographers used to work with different kind of maps, and they are using different techniques for preparing the maps as per their study. So these are the some way they are cutting the edges like that, and they are plotting, they are arranging each of the part and preparing the world maps. But when we are cutting like this way, and the distortion is coming here, right? So in this map you will see which area is this? I think Africa, South Africa, right? Africa it is. African continent.
Yes, sir. Yes, sir.
Yes, but in this it is followed by some projection system, but the information, due to lack of information, we can't study this portion. We can't study this portion. We can't study this portion due to lack of information. So these are the distortion of a projections. These are the limitations. So each and every projection has its limitation. I will discuss one by one. This is another kind of making maps as per the projections. That is a polar genital shape map, and previously used. But after that, a map projection is a method for mapping spatial patterns on a curved surface and the earth surface to a flat surface. We all know that. So an imaginary light is projected here, and we're plotting the globe in the piece of paper on a flat surface, right? What it is called? With the help of a light, that projection is called geography student. With the help of light, when we are plotting our Earth surface, then what it is
Sir,
called?
perspective projection.
Right. Perspective projection and non-perspective projection. Okay, good. And now cone is developed as a surface. When the cone is developed as surface, with the help of this conical projection surface, we can map a small area, not a wider area. How we cannot project the whole surface area, because it is a cylindrical it is a conical projections. So with the help of conical projection, we can map these portions only. We can map only these portions. Here the area will be not distorted too much, but it will distort. There will be distortion, there will be some error, but plus minus we can take this area for our map projection, but we can't map this area, we can't study on this area also, because it will be enlarged. So some of the limitations is also available in the conical projection also. This is the principles way. If I get more time, then I will discuss all the things, how the mathematical formula and the principle followed to prepare any map through the simple conical way. So this is the principle, that 2 pi r cos theta divided by 360. This is the principal theory, and with the help of this theory, we can plot the whole plot the surface area into a map as per our projection system. So this is cylinder. It is also another type of projection, that is cylinder as a developable surface. Tangent cylinders, how it is when it is a normal shape like this on a cylinder, and we are putting the globe into it, and then we are plotting. So in transverse case, we will put it, and in oblique case, if we even put our globe, and we can map the globe as per the cylindrical projections principles. These are the principal way, and these are the calculations. Okay, so I am skipping how the India is mapped by this bones projections. There are several kinds of. Okay, so plane as a developable surface, planar projection surface, how it is planned, and these are different kinds of projection systems, that is polar projection, equatorial projection, oblique projection, mnemonic projection, stereographic projection, and orthographic projection. So each and every projection have their own principles and their own representation. There are some aerial differentiation, angular differentiation, and the size differentiation also is there. And each and every projection have their own quality to represent the Earth surface, right? So you can't use that. I want to use polar projection for my study. You can't, because only polar region can be mapped through the polar genital orthographic projections. And similar way, if you want to plot the whole Earth, then it really will be based. And another way, the cylindrical area and the marketer projection will be also based for the flat surface, if you want to map the whole Earth. So there are some limitations for to map the Earth surface. Polar genital, okay, map projections always introduce error and distortion, what I already discussed. Here you will find that the map projection is showing with the given map projections. Okay, so the same area showing in different way. Here it is, which is the map, here it is not mentioned. Okay.
Alaska, sir.
Yeah, I know it is Alaska, but the projection system, it is not mentioned here, that which projection system had been used in the both map. From here, we can just realize that this is one kind of projection, and this is another kind of projection. Both the areas showing in the display, but the differentiation or aerial destruction is there. This portion is like here it is, and the shape is different in this picture, right? But if you focus on this shape, you will focus on the shape. So both the different system of projections will display the area in a different way. Yeah, here it is. The three type of projection is used in this map. That is, red lines are given as the marketer, and blue lines are defining as a Lambert conformal conical, and this is the UN projected latitudinal longitude projection that is defined in the green line. See, the same area, but different projection system will give you the different orientation and the obligations, right? So from there, what you say that this is the right marketed, Lambert, or even projected? How you can say this is right? Do you have any idea which we can say? कैसे हम लोग बोलेंगे कि भाई ये पोजीशन सही है और ये based on what parameter we can say?
Sir, according to the requirements, we can consider the right one.
Not only requirements, we have to focus first things that the shape of the area will be good, right? So देख के ऐसा लगे कि चलो एकदम परफेक्ट लग रहा है मुझे, हाँ ये सही हो सकता है, क्योंकि अगर if I take the blue lines, if it is look like a oblique directions, right, angular direction, and if we say the green line also some kind of oblique direction, it is like downing the eastern side. But if you focus on the red side, it is straight and a 90-degree perspective. It is a flatly planned to the paper, and it is a straight forwarding. So we may say that the market projection, this area is projected by marketer projection, is the best way of representation of the area. But in this case, Lambert conformal conical and UN projected latitude and longitude, these both the projections are not good to work with this projection system. So marketer will be best for this area, right? So this way, another Albert equal area and Lambert conformal conic, same the portions. You see the distortions. The differentiation is likely into almost 0.6 to 7 centimeter stretch, right? The brown line is below the green line, and here the brown line, yes, here in this portion the green line is expanding. Here the brown line is squeezing, but here the green line is expanding. So the area is expanding and squeezing. So the stretchable condition. So which we will take? That is good for our study, and we will plot each and every information on the earth surface or in the projected area. It is depends on the projection system, because if our information is stretched to 1 to 2 centimeter, then it will be replaced by it will define by the scale, and it will be when I'm saying that I am focusing on a object which is located on the Jaipur, and when I use the Lambert conformal conical projection, and it is showing that it is located on Delhi, so almost 200 to 300 kilometers stretch is there. So the information goes to one place to another place, and that is not right. That is totally wrong, right? So this is the functionality of a projection, that we have to choose a proper projection system, which we will use to plot each and every information perfectly and almost accurately. Not accurately, because no projection will give you the exact location of any object on the earth surface, but more or less, if we have even our GNSS system also a 5 meter to 2 meter error is there. Have you used any one of you use the Google Map? Everyone is using Google Map, but when you putting one point to arrive, then you see the Location distortions? Error? Do you have any experience? Hello?
Yes, sir. On projection, it is showing.
Due to the projection and due to the projection and the spirit shape of the art, we are facing problem. When I said मुझे अगर कहीं जाना है, if I give example के मैंने दिल्ली रेलवे स्टेशन पे या दिल्ली एयरपोर्ट पे मैंने उतरा, अब मुझे कोई एग्जैक्ट लोकेशन पे जाना है, तो मुझे I had said to the Google map that I want to go to this place, and I put it and save the location. But when I reach the exact location, I unable to get the exact location, and I unable to reach the my desired place. It is happening. It is reality because of only the projection system and the spirit shape of the art. कोई भी प्रोजेक्शन आज तक ऐसा नहीं हुआ है जिसमें एग्जैक्ट लोकेशन, एक्यूरेट लोकेशन वो तुम्हें बता दे. इसका मतलब कुछ भी मैप हम बना रहे हैं, कुछ भी कर रहे हैं, that is not. Some of the people are saying that my map is 98% accuracy. My map has 99.9% accuracy. It is totally wrong. As per my observation as a cartographer, I can say that this statement is totally wrong. No one can say that my map is 100% or 98% or 95% accurate. Yes, it is as per your wishes, it is 95%. As you mapped in the, as per your category, as per your principles, you have you have put the materials in the map. It is 95%. According to your software calculation, it is 95% accurate. But वहां पे भी एक ऑप्शन रहता है जहां पे you can say that is these training samples are right or wrong. बट हम जब उसको फील्ड में जाकर वेरी करते हैं तब हमें पता चलता है कि भाई ये तो गलत हो गया. Because of projection system and the spheroid shape. अगर हम एरिया पे जाके पर्टिकुलर एरिया पे जाके सर्वे करके इंस्ट्रूमेंट के दौरान ट्रिगोनोमेट्रिक सर्वे करके अगर हम प्लॉट करें, देन इट विल बी 100% राइट. फिर भी 100% नहीं कर सकते क्योंकि अगर हम इंस्ट्रूमेंट भी यूज कर रहे हैं तो इंस्ट्रूमेंट का क्या एक लिमिटेड एरिया. इफ आई मैप 2 to 5 किलोमीटर, देन इट विल बी ओके. 2 to 5 किलोमीटर में भी we will get 99.9% accuracy. बट अगर मैं 10 किलोमीटर से लेकर 30 किलोमीटर का मैप करने जा रहा हूं with the help of instrument, then it will give you error. It is only just because of the projection systems and the spirit shape of the art. Okay, so distortion may be minimized one or more of the following properties, that is safe, it is conformal, distance, equidistance होना चाहिए, and direction, true direction होना चाहिए, and area, equal area. If you follow the conformal, equidistance, and true direction and equal area, then the distortion will be very less, and we will get the exact location of any object on the earth surface. Now, if we say the input is unprojected and angles, latitude, longitude, that is x, y, and when output is projected and Cartesian coordinates, that is f into x, y, that is latitude and longitude. So we can plot and we can get a output from there. And how do projections work on a programmatic value? It is I'm skipping because the time is less also. Projection is a vast thing. We have to take almost 1 unit in our syllabus, and it will take almost 10 lectures on projection system. We have to focus on each and every projection system because if each and every projection has its own principles, right? So it will take each and every projection will take 1 hour to study. Now, here the picture is showing you see the map differently, but the data have not changed, right? The same area, same focus, but the color integration is different, but the data have not changed. That is a pictorial representation of the data. Now, how ArcGIS handling? Because ArcGIS is handling in a projection that is different projections, coordinate system, and datums is also most important. Now, geographic position system. Here in this map, it is this is the North America, and see Albert's conical projection. The whole Earth, already almost the whole Earth plan projected by the Albert's conical projection, and it is shaped like this. Is it true? Is it acceptable? Now unmute yourself. Is it acceptable?
No, sir.
Yes, because only here the main thing is all areas are proportional to all the same areas on the Earth. Right? This is the main problem, that all the shape is distorted. Australia distorted. Here the South America लगभग ठीक ठाक है, बट ये इंडिया स्ट्रेच हो गया है, एशिया रशिया सब स्ट्रेच हो गया है. तो इसका एरिया में क्या, अगर मेरे पास 2 बीघा जमीन है और किसी प्रोजेक्शन मुझे ऐसा अप्लाई कर दिया जिसमें 2 बीघा जमीन मेरा 1 बीघा में ट्रांसफर हो गया, देन क्या करेंगे? मैं छोड़ दूंगा? Can I accept?
No, sir. No.
No, sir.
No one will accept, right? So projection system is most important than whatever we use. So as per the study, this is another example. This the shape of the same area defined in defined projections. Now distortion is severe near the poles. I will give you one example. Write this one. The whole Earth, whole globe, I want to plot according to the Lambert azimuthal projections. But see the how this is going on, like this. The orientation already changed. Exact is it should be like this, but it is this. And the marketer cylindrical equilateral projection, it will increasingly distorted toward the polar regions. With the help of this projection, you can map the whole. You can't map the whole Earth. If you want to work with this portion only, middle portion, then you can easily map and distortion will be very less. But if you map this area, the polar area, this will give you the wrong information and the wrong measurement, and the whole map will be wrong. So now this Miller cylindrical. This area you can map through this cylindrical area projections, and these are the shape, area, and direction, distance. What is here? The shape is minimal distorted, and the distance, the correct distance, is measured along the equator, right? With the help of cylindrical equilateral projections. Another example is like that moloid projection, cylindrical projection. Here it is also same thing. This area is already stretched. Only this area is unstretched. African region, right? And this is also stretched. This is also stretched. So these projections will not be applicable for the whole Earth. See, this area is stretched. Okay. Orthographic projections. I will give you some example because the time has been gone already 100. And coordinates, distance, angle. Okay, coordinates. Right. Map projections and coordinate systems is. Universal transverse marketer projections will be appropriate. Yes. Now we are using this coordinate systems as a marketer projection, WGS 84 projections. With the help of this projection, we can measure, we can map almost whole of the Earth, and except this polar region. But the middle of the Earth we can map through this way, and these are the numbering. These are the numberings of the grids where we have to follow, and we have to assign each an area. If I want to work with Gujrat state, then I have to follow the 42 region as per the 1984 WGS 84. So if you are working on Rajasthan, this grid you have to follow. If you are working with Maharashtra, like this portion, you have to follow this Q and zone number 43, right? So there are several kinds of zones are already divided as per the projection rules. Datum, the system has not allowed to place a coordinate system on the Earth's surface. It has here the distortions is with the help of a datum. We can say initial point, secondary one model of the Earth, and the datum is the local datum is the perpendicular and trigonometrical point of the Earth's surface on a particular point. So this datum is also the datum is required in each and every projection. And commonly used datums in North America is North American, but in India we think Everest we are using, and before that we had using Everest and datum. Now the WGS84 datum is also are using in the present study. How the special things are differentiating UTM-36 and UTM-34 zone. You know, this place is like that. The UTM projection here in the map, it is showing the UTM-34 zone, but the African lakes, it is showing the UTM-36 zone. So that's why it is showing there. But the reality is the exact location of the lakes is here. So if you change the zone number, then the location of the object also will be changed. So that is you have to take care of it. The same projection will be used in the same study, not different projection, not different projection or the different zone will be permitted to you. So it will give you wrong idea. And now I will give you one example, that is the good map. What will be one of my map I will show you like that. If you want to map a particular, there
Is voice audible? My voice is audible?
You are
Yes,
audible,
sir.
sir.
Yes, sir.
It seems there is some issue related to some connection from Dr. Ajay's side. Dr. Ajay, we cannot hear you. Dr. Ajay.
Okay.
Maybe he will be joining again, so we have to spare last few minutes with him. How was today's session?
So much
मेरी भी आवाज
information.
नहीं आ रही है क्या?
Sir, it was good, sir. आ रही है सर आपकी आवाज?
So very good and so much information to take, sir.
I am very happy with Gulati. He is improving a lot. I'm highly impressed. Because the kind of confidence you see, whenever you are interacting with anyone, what does it does when you're in the initial stages, it builds your confidence, it builds your gesture, it gives you a boost. Because today what we are is all because that we proved ourselves, we backed ourselves. Because at end of the day, you will be having 14, 20, 30 persons working together, but you have to back yourself. Yeah, Dr. Ajay Das has
yes.
joined again. Sir, please, sir, please.
I forgot. I forgot that the link has been broken.
Okay.
So how much
Okay.
time it is?
Sir, because we have got lunch time from 1 to 2. So last 5 minutes, sir. Wrap up the
Okay.
things in 5 minutes. Sir.
Okay. So the technical glitch was the last 5 minutes, right?
Yeah, yeah.
Okay. So I will show only one thing. Just put one thing. Just a minute. I will show you one last of the thing, good map and bad map. I want to share just a thing. Just 2 minutes. Can you see?
Yeah.
Hello.
Open
Yeah.
the
Okay.
map.
Okay.
Open your
Yeah.
map.
Yeah.
Yes. Yes.
Yes, sir. Yes, sir.
Can you see? So, what is the example of a good map? You know, there should be a title for the map, a specific title what you are showing in the map. That is land use land cover map of Mundra Port region, Mundra Taluka, that is located in Gujrat state in India, and used by list 3 satellite data December 2017. Right? The title is clear and everything is clear. The base
Ji sir,
approach.
ji sir.
Okay. Now you have to focus on the location map, because this is Mundra where it is located. So we need to focus on that. This is the world map, and this is the country map, and this is the state map, and this is the district map, and it is the taluka located in this, and this is the sketch of the study area, right? So a proper location index maps will be there, right? Now the thing is, whatever components you have used and whatever category you have used for your map, that is your index. I had used several, almost 15 to 16 category, land cover category. So here it is already mentioned, right? Okay, sorry. Now you have to locate on, now you have to focus on the directions. True north, the north side is this, and the south and east west. So according to this direction, you can plot this map. I have to use both type of scales, that is one statement scale and the graphical scale also. So from the both way, you can calculate each and every category from the map. And also I had mentioned the land use land cover distribution with the aerial differentiation, the how much area it is covered by each and every. So agricultural and horticultural land, it is covered by the 14.3 square kilometer area. It is not mandatory, but if you put in on your map, then the map will be clear. Anyone can see and can understand the map, what you want to show, what you want to show the others, right? So this is one kind of good example, and almost it is required that the latitude longitude is already mentioned in the map. And so some of the people are latitude longitude also mentioning in this portion also, so that is not accurate, you know, क्योंकि अगर मैं इस साइड में भी latitude longitude देखा था तो इसका फिर alignment हो जाता, but it is not to scale map, right? Here should not be the latitude longitude. So that's why only this portion has latitude longitude. So these elements are latitude based on the latitude longitude. Okay, right? So this is one kind of good map, and if any one of these components is not available in the map, that is called not a good map or a real map, right? So then any other information you want to put for your purpose-oriented map, it is acceptable. But these are the main things you have to follow. That it should be needed to put on the map. That these are the elements and the parameters should be mentioned in the map. Okay, so it is one example of the good map, right? Understand, everyone?
Ji sir. Ji sir.
Okay.
Yes, sir.
So,
Yes, sir.
okay, so now it is your lunch time, right? Sir, over to you. Thank you so much for hearing. I got less time, and due to lack of arrangement, I am unable to rearrange all the things step by step. But okay.
Very informative and interesting session, sir. Thank you so much, sir.
Thank you so much.
Any
Thank you
comments
so
from
much,
any
sir.
questionnaire from any of the students to
Yes,
the
yes.
invited speaker? We can, if there is question, we can take few. If not, then I'll give the vote of thanks.
Sir, I have one question.
Yes.
Ajoy sir, there is a concept called map indexing.
Yes, map indexing.
So I just want to have little information on that. If you can please put up some light on it, sir.
Yes, map indexing, right. Again, I want to share the screen, and I want to show you. Yes, you know, when you are planning to show your map, if you have categorized more than 20 or 25 parameters you have used for your map, then you have to mention in a proper manner, and you have to use a proper color also. You know that if you showing the mud flat area on a green or red color or a different shade, like it will be focusable, but it should not be acceptable, right? If you want to create a similarity on your map on a color basis, on a choose of color, then it will be based on your expertiseness. See, in this map you will find each and everything. Here it is one odd color is given, that is violet color. It is open prosperous julifera. It is a invasive species we want to focus. to the government that these are the area, for these are the vulnerable area we want to focus. That's why I had given this color. So this is object oriented color assignment. And you have to, if you give it to the light green or pale green, then that will be better, that will be best. But if you want to take some extra focus on the element, then you have to take one focusing color regarding the other colors, right? So color assignment is best. And the color of choice, what color you are choosing for your categories, the what is the category, here it is cropland, it is like this one, and agricultural land I had followed the yellow color, because you have the limitations. NRC guideline, you have to follow the NRC guideline, and they had already given the instruction that you have to follow for this category, for this color, and you have to follow that, because you have to follow the national rules and regulations for describing or for displaying your elements to the maps. So it should be a proper manner.
Okay, sir. Thank you.
Okay. Any other questions, please? Any other?
I feel that most of the questions are cleared, and that's why there is no question coming up. Now, on behalf of Center for Climate Change, Suresh Gyan Vihari University, Jaipur, Rajasthan, I give you my vote of thanks, my thankfulness that you have spared your time with us. You have enlightened our students with the basics of map, elements of map, what are the different kinds of projection system, whether you talk about conical, cylindrical, azimuthal projection system, or whether you talk about what are the different kinds of map, whether you talk about a small scale map or large scale map, medium scale map, or you talk about the various kinds of UTM projection, datums, coordinate system. So in this 1 hour, it was a very enlightened sessions where you covered each and every aspects of they're very important, because whenever you're creating a map, GS is not from the morning itself we'll talking about digital cartography. So cartography is the final output of the entire exercise, the entire software, the entire modeling, the entire output, whatever you have done should be correctly represented. So if you have done a lot of work and if you have not represented it well, again it will be rejected. And you have done less of work, but you have properly represented it in a proper scientific way, your paper will be accepted. So I thank Dr. Ajay Das from Gujrat University that he has made our participant, us, our team members, our students efficient in the various kinds of Cartesian coordinate systems and projection system. And with this, I'll conclude today's first half. In the second half, again, we'll be joining at 2:05 for our practical trainings on QGIS. So I request all the participants to please complete the earlier exercise what we did yesterday, and today download all the data sets from the DST websites pertaining to the practical exercises that we'll be doing today. Yesterday we completed point data creation, line data creation, georeferencing through toposheet, then image to image. Today we'll be learning creation of polygon features, then attaching the non-spatial data to the spatial data, like if you've created a point, how to label it, and finally we'll be preparing a map. So that's why today we have in detail taught about the different kinds of projection, because today finally all the layers, all the things what you have done, the basic exercise will be represented in the form of maps. So that's why we have taught you all the basic principles we have covered. And with this I end today's session. We'll meet again at 2:05. Thanks a lot, Dr. Ajay.
Thank you so much, sir. Thank you so much.
Thank you.
Yeah.
Okay, bye.
Thank you. Thank you, sir. Thank you.
Thank you all.
Thank you.
Thank you,
Thank
sir.
you. Thank you. Welcome. Welcome.
Thank you, sir.